Hello everyone, I'm Kisle Kumar. I'll be presenting on the topic of movie recommendation as part of my final project. The presentation will focus on the LightGCN model. The goal of this project is to design a movie recommendation model using graph-based collaborative filtering technique and apply these techniques in different domains. These are the technologies used as part of this project. Now the question is, what is LightGCN? LightGCN is a graph convolutional neural network architecture, and it is simplified for solving collaborative filtering use cases. This diagram shows high-level model architecture. The GCN architecture is simplified by removing operations such as self-connection, feature transformation, and non-linear activation. Next question comes as why LightGCN is light. As described earlier, it is simplified version of GCN architecture, and it only contains the essential components needed for the collaborative filtering. And this simplified version makes it more efficient and light. This is the high-level architecture diagram for this project. Movie rating data is taken from group lens. Poster URL is taken from a public GitHub repository. The LightGCN model code is taken from Microsoft's recommender library, and some modifications are done. And Jupyter Lab is used as execution environment. Now I will show the installation steps for this project, and then we'll show the execution in Jupyter Lab. As part of demonstrating the installation, I'll be using PyCharm environment. Any other IDE can be utilized as well. As you can see here, I have already opened the project folder in the IDE. Now, next step will be setting up the virtual environment. We'll go here, go to settings. There's no interpreter, we'll add it. Add. We could have used some of the existing one, but yeah, let's create a new one. To location. Okay, it's creating the virtual environment. It will take some time. Now virtual environment is created. Now, the step is to install the needed packages. So you can see here in that part of this particular project folder, there is a file as requirements.txt, and these all are the needed libraries that we need to install. So let's install those. So it has created a virtual environment named recommender. Now we'll just see which path we are in, just to check it. So we are in the right path. So now package installation started. So we'll wait for some time. See, all those packages are installed. So as we'll be using Jupyter Lab environment as the execution environment for this project, so we have to install that as well. So I have not added that as part of the requirement.txt because that is not kind of core of this particular project. Now install this Jupyter Lab library. Now this installation started. Now you can see installation is done. Now we have to start this Jupyter Lab environment. So let's start that so that we can start using this notebook. So now you can see that Jupyter Lab environment is created and the server has started. And we can see this notebook is available here that will execute as part of this project. Now we can check all this code as well at high level that what all this LightGCN directory contains. So this particular code is taken from Microsoft recommended library from GitHub, and some modification has been done. Even you can see in this notebook, this whole path has been changed. You can see there are module related to data set that is used to download the data. This is the folder where model is there. You can see this LightGCN, this is the model code. And these are the evaluation related modules. And there are some util library that has been used. Now let's deep dive into the notebook. As we have already installed all the requirements, we don't have to run this, but let's say if we are using already some existing environment, we can still install these packages to run this notebook. So let's start the execution. This is the all these needed libraries. And the second part you can see here, we are getting all the needed modules from the LightGCN. And this particular code is taken from Microsoft library. And it has been modified to a certain extent to get some reporting results. Now we will get all the needed modules from there. You can see we have all the needed modules like getting the data set, training and test split, as well as all the main model, that is the LightGCN model. So you can see all these details, and we can go through this code and identify the all these modules that is available here. So now everything is imported. Let's set some hyperparameter here. As part of this project, we are just identifying just we are setting k as a 10, and for any recommender problem, we try to see that what is the k value, that how many top items we wanted to recommend. So here we are setting it up as 10, and movie lens data has different sizes, but for this particular project, I'm going to use 1 million records, and these are the set parameters. So let me run this. These are the config files details and all that is being used internally. So yeah, we have all the possible setting available there. And these are the files for embedding that we will store by end of this training. Now let's get the data. Okay, data has been pulled because the data loader function, everything is already available as part of this LightGCN library. Now we'll get item data. Now we will do train test split. This is the stratified version of train test split, so that we have similar kind of data available in train and test. That is already implemented by Microsoft, so we are just utilizing it. There's high level details. Now, as part of this, data is being processed to ensure data is in the format so that it can be utilized by the model. So let's get that done. Now these are the hyperparameters that already has been set on top. So we will just use this. Now we will just form the graph to see that how it looks like. So it takes some time. Let's pause video. And you can see the graph is created and it looks very dense because it is a huge data set. It's, there are 1 million ratings available. So this is the graph that has formed. Now, just to see that how adjacency matrix looks like, this is how it looks like. Now we will create the training, and we'll create the model and we'll start the training. So this LightGCN model, the code, as I was saying, that is already available. So this is the code here. So now we are going to use this particular code that is available from Microsoft GitHub repository to create the model and do the training. So now we are initializing this model, and all the hyperparameter and all the data, everything is already set on top. Now we will start the training. So this will do the training. And as part of the code, I have done some modification to the original code so that we can get this loss details, and that will be useful later for visualization purpose. So let me start the training. So training has started and it will take some time. So I'll pause the video, and once training is finished, I can resume the video. Now we can see that training has finished, and it took almost 45 minutes to train this model. And you can see here that with every epoch, the training loss is captured, which is sum of matrix factorization loss and embedding loss. And additionally, with every 5 epochs, the model is evaluated on the test data, and precision, recall, and other metrics are captured. Now let's plot the losses. Here you can see that loss has decreased over time with epoch. Now we can check the trend of evaluation metrics that is captured every 5 epochs. And here we can see that recall and precision both has improved with increasing number of epochs. Now we can evaluate and check the results on the test data, but this evaluation can be done on any other data set with similar data structure. Is some sample results from the recommendation. Now let's print the evaluation metrics. Yeah, here you can see that map has come as 0.08, NDCG is 0.42, precision at 10 is 0.38, and recall at 10 is 0.14. Now we can check the movie rating distribution by different users. Based on results, we can see that there are total 6,000 users, and minimum rating by user is 15, maximum is 1736, and median is around 72. Now, as just for the sake of demonstration, I have downloaded this poster URL dataset so that we can show the posters as part of this demonstration. And this has been taken from this GitHub repository. And now I will merge the poster data with the recommended data. Now this is how the final data frame looks like. Now we will utilize it for further demonstration. This is the function I created so that we can pass the user ID and get the details for that user. Mostly it will print the top 5 rated posters and top 5 recommended movies. And also it provides details about the genre of the movies. It provides all the genre for the rated movies by the user and genre of the top 5 recommended movies. Now for this demonstration, I have selected 3 different users, and those 3 different users, one user has rated a lot of movies, and the second user has rated median count of movies, and the third user has rated very less number of movies. And now we can check the results. Okay, so this is the user. You can see this top one shows poster of the top 5 rated movies by the user, and these are the details for those movies. And you can see all genre, as this person has watched a lot of movies, so we can expect that a lot of genre will be there. And the bottom part shows the recommendation details. These are the top 5 recommendations for this user. And you can see the genre of rated versus genre of recommended are common as expected because this person has watched a lot of movies. Now let's check for the second user. You can see the top 5 again. It's the top 5 rated movies by the user. You can see the rating is 5. And the bottom one is the recommended movies. And this, you can see the prediction score is in descending order. Here we can just check the genre. Genre is also common in this case. And let's check for the third user. This person has watched or rated very less number of movies. These are the top rated movies by the user. And these are the genre. And these are the top 5 recommendation. Here also you can see genre is common. Now, as part of this whole training, when training gets finished, we can save this embedding for user and item, and that can be used for future purpose. So let's save it. Now, this has been saved at this location. Now we can try to use those embeddings to check some results. So this section is just doing some processing. It's a user embedding. Some data processing is needed. Same thing to load item embedding. Again, some data process was needed. Now we'll get the inference for a couple of users. This is one of the user. Let's see how result looks like using these embeddings. So the top part shows the similarity score of the top 5, and these are those top 5 items like those movies. So for this particular user, this is the ranking score in descending order, and there are those items. Let's check it for the other user. Similarly, you can see this is the ranking score, and these are the high score movies for that user. And this concludes the demonstration part. After seeing the overall demo of this project and observing decent recommendation results, as a summary, we can say that this is a lighter graph-based model tuned to solve recommendation use cases. Faster training and promising evaluation metric results make it a promising model to solve recommendation use cases. Though this model is good for recommender systems, this might not be useful to solve graph-based node and link classification use cases, where just linear interaction between the user and item is not enough. And finally, I can say that there are still area of improvements and that can be explored further, such as deeper dive to understand the overall architecture and ensure this model works decently with other datasets as well. Hyperparameter tuning should be done to identify best parameters to get the robust model. And this model is built using TensorFlow, but I would like to utilize PyGeometric library to build this model and check the results. And with that, I conclude my presentation. Thank you.